If the fourth term, 10th and the 16th term of the GP are respectively x, y and z, prove that x, y and z, they themselves are a GP. See, anything to do with GP, AP, any kind of series, the funda is that we need to know the first term and the common ratio. In this case, common ratio. So on that basis, we'll express x, y and z, and then we'll be able to prove whatever we want. Right? So again, whatever series we are talking about, whatever kind of series we are talking about, there will be some basic aspect. It can be sum of, it can be a number being added that forms an arithmetic progression. It can be a particular number being multiplied or divided or so on and so forth, raised to power of some particular integral that forms a GP, right? So the point is, we need to have a basis. We need to have a commonality between x, y and z. Only then we can talk about or prove that it's a GP. Does it make sense? So how do we establish that commonality? What is the principle over here? Establishing the commonality. Okay. So the underlying principle is establishing a commonality or a relationship basically between x, y and z. That's the principle. Okay. So with this in mind, we can start off the answer with let the GP's first term be A and common ratio be R, right? Next, we have been given, well, quite a few things. So for that, we need to make use of an, which is a into r to the power of n minus 1. Okay, making use of this. So we have been given the following: a of, what is it, a4, which is x, which is nothing but a into r to the power of 3. Right? Does it make sense? Then a10, which is y, which is a into r to the power of 9. Then we have a16, which is z, which is a into r to the power of 15. Okay. So with this set of information, what is that we have to prove? We need to prove that x, y and z are in GP. So how do you tell something is in GP? Well, they themselves should have a common ratio. So how will we go about doing this? So the proof will start off with finding y by x. Okay, y as per this is a into r to the power of 9 divided by a into r to the power of 3. So on dividing and cancellation and all of that, it is a into r to the power of 6. So this is a to the power of n by a to the power of m, which is a to the power of n minus m. Okay. Then we have z by y. So z is a into r to the power of 15 divided by a into r to the power of 9, which in turn is a into r to the power of, sorry, not a will get cancelled. So this is basically r to the power of 6. So with this two set of, information, what can we tell? So we have, therefore, from 1 and 2, right, as the ratios are same, the or x, y and z are in geometric progression. Does it make sense? The ratios are same. X, Y, and Z are in geometric progression. This implies, yeah, that would be better. Okay, right guys, so here the underlying principle is establishing a commonality, that is expressing in terms of A and R. It's just another way of talking about expressing in terms of A and R. With that basis we can prove, so any kind of proof, that is the underlying principle. Any kind of proof which deals with such natured question.